So inside of Unreal, I was able to test out doing some advanced animation blending directly inside of Engine, just using control rigs and slots. So you can see in this example here, there's just a basic dance animation that was retargeted from Mixamo. You can see in this bottom right, there's the same animation that you see above, but it starts from a car that's being transformed into the dance. You can see here in the bottom left that it's just a partial transformation where the car is half of the body and the standing transformer is the other half of the body. And in this top left example, you can see the dance flipping directly into a car itself. So we had Sequence Baker and we wanted to be able to test the tool out on some complex animations. And we thought that using a transformer would be a pretty good place to do that test. So the prerequisites to follow along this tutorial, you're going to need to understand how blueprints and skeletal meshes work, something similar to like a metahuman structure, where you have multiple skeletons that are set on top of each other with copy post or mesh. So you're going to need to know a little bit about the animation blueprints. You're going to need to understand how to use layered control rigs inside of Sequencer so that you have different control rigs on top of different skeletal meshes, so that they operate in a specific order. Again, similar to like a metahuman where you have the body control rig on the body and then you have a face control rig on the face. In this example, we're actually just using the same skeleton for every single one of these. Another reason that we're using layered control rig is because there are a lot of bones in Transformers. Bumblebee has almost 400 and Optimus Prime has a little over 700 bones. So layered control rigs are just a lot faster inside of Unreal than the baked control rigs. And the last thing you're going to need to understand is how skeletal mesh works with slots and curves. So the curves would be something similar for like blend shapes. In my case, I just manually created all these curves on the skeleton as well as the skeletal meshes. And you're also going to need to understand how the slot manager works on the skeleton. In this case, I created all these different slots for the different body parts that I wanted to transform on the transformer independently, even though they're using the same animations. In the example Bumblebee sequence, the only two animation clips that I will be using is this car animation that's a single frame and this dance animation, which is about 200 frames, which I retargeted from Mixamo character onto Bumblebee, and I cleaned up with the qoobit sequence baker tool. It basically helped me pin the toes to the ground and the elbows and stuff like that so that they don't slide around. In the Optimus Prime sequence samples that I'm showing, there's basically three animations here. There's one where he's being transformed into a truck, which was slightly modified inside of Houdini. The animation came from the Turbo Squid model, and these two animation clips, which were retargeted directly from Mixamo characters. So this is the blueprint structure that I used for both Bumblebee and Optimus Prime. It's basically three skeletal meshes with two animation blueprints on them. The first two skeletons, the body and the transformer, it's basically a copy of the full skeletal mesh, and it just has hidden materials on every single section. Alternatively, you could just create a copy of this skeleton with a triangle mesh skinned onto one of the bones. To me, this whole thing was experimental, so I was just using whatever I had in Engine. So in this example of a layered blend per bone, you can see that I'm using two animation clips piped into the layered blend per bone and then using that into the output pose. I have a variable here that's blending between these two animation clips, and I am making the blend happen at spine 01, and I'm excluding clavicle L. So now we can see here that he's dancing with the weight blended fully to 1. I take this weight and I drop it down to 0. You'll see that Optimus Prime has just the full dance. And then if I blend this back to 1, he's in a partial car. So you'll notice here the clavicle L here is set to -1, which means that it's removed from the branch that's being blended in, which is spine 01. If I set it to 0, and I hit compile, you'll see that it's the entire truck here being animated on, and his left arm isn't being excluded. If I were to add this back to -1 and hit compile, you can see that he's animating again, but his left arm is still in the standing transformer mode. In the final animation blueprint that I have for Bumblebee, you can see here that it's a little bit more complex, but I'm just layering on different slots in a specific order. If I did not layer the animation slots in this order, something would just go wrong. This here is the second animation blueprint, and basically what happens here is it's just a copy post from mesh. So I used the qoobit sequence baker tool to clean up the Bumblebee animation that I retargeted from Mixamo. And in this example here, I'm using a CRU curves, which is a control rig that just puts the curves from the skeleton onto the skeletal mesh. And I also used a CRU FBFK, which is basically a copy of FK control rig that's inside of Unreal, but gets around some of the issues that we found. In the slot example, I'm actually using the features inside of the anim sequence bake mode, which is being able to change the slot name on animation clips really easily, rather than typing it in manually and messing up the name a bunch. The characters being used inside of this demonstration is Optimus and Bumblebee, which you can find on TurboSquid, and the animation clips are retargeted from Mixamo. Both of these characters are heavily modified inside of Houdini to make them metahuman compatible so that I can use the control rigs inside of Unreal on them, as well as test our tools that we made against it to make sure that they work on the metahuman skeleton in any size, from mannequin to giant robot that transforms. So here's the animation running directly in Engine using the blueprint setup. You can see Bumblebee dancing and then transforming into a car here. So let's just pop inside the blueprint to take a quick peek at what's going on inside of it. So inside this blueprint, there's just 3 skeletons as explained inside the slides. The first 2 skeletons here, you can see it's just using this skeletal mesh with no visible body. And then the last one actually has the visible body inside of it. Now let's take a look at the animation blueprints inside of these last 2 skeletal meshes here. You can see here, this is the more advanced setup for the layered blend per bone with the very specific stack setup. It's using a copy post from mesh, which just has the first 2 used attach parent. So it's copying the animations from this first skeleton and then copy curves. So if I have a control rig with curves on it that are on this body or on the blueprint itself, it'll drive up the chain so that the curve values are being used inside of this animation here, which is basically piped into these values you see at the bottom, which control the weights for the slots. The slots that I'm using here, I'm using the full animation. So this goes every single bone except for the pelvis and the root. The chest, which goes all the way up from the spine 01 all the way to the head and the arms, but it's removing the arms inside the settings. And then I have 2 arm slots and 2 leg slots down here for just the appendages. So if we take a quick look through the index of the layered blend per bone here, you can see here thigh R, thigh L, clavicle R, clavicle L, spine 01, and then clavicle R and clavicle L are set at -1 so that they are not included in this branch filter. And then the full slot is being controlled by the hip, spine 01, thigh L, and thigh R. So that's every single bone except for the root and the pelvis. And the reason for that is, say for example, if I put slot full at the bottom and I had leg R at the top, I would not be able to get the result that I'm looking for, which is either blending the entire thing all at once or blending just partials. At the end here, the layered blend per bone is going directly into the output pose. Now let's take a quick peek at the second animation blueprint. You can see that it is just a copy pose from mesh and it goes directly into the output pose. The settings on it are pretty much the same as the other animation blueprint, which is use the attached parent. So it's copying the animation with all the transforms on it from this second skeletal mesh. And then it's copying all the curve values. So I can put the curve values on any of the skeletons and it's going to read all the way through to the end. So now that the blueprint is covered, let's take a look at the sequencer. So because the body is actually the root of the animation blueprint here, I could decide to put the animation clip directly on the body, which I haven't added, or I could just add it directly onto this blueprint. So in this case, I added it directly to the blueprint. So the animation, the dance animation is running directly as the first layer of animation. CRU curves, which I've added from the sequence baker here under CRU. If I were to click on curves and press this button here, it would add a layered control rig to this character. You can see here that I just have keys that go from 0 to 1. And that just tells when these animations should trigger from the second skeletal mesh. So if I open up the second skeletal mesh, you can see that I just have 1 frame animation, just copied a couple times here, and I renamed the tracks here to indicate which body part that I want to control. So if I click on this actual animation clips, if I were to be inside of animation sequence mode. I could see which slot it's on easily just up here. So if I'm inside of the animation sequence bake mode, I can actually click on one of these clips and see which slot is actually being used on it. And I can easily switch them by clicking on this arrow here and then just changing to another one of these values. And then now that I know that the animation is running on like this half of the sequence here, I can actually just drag and move these keyframes here to indicate when I want the car to actually transform. So if I wanted to keep some appendages not in car form, I could just move them directly off. So let's just grab right leg and the right arm. And you can see that half his body is not a car. Originally, I had the animation blueprint running on the first skeletal mesh, but I found that it just seemed a bit unstable when I used the layered curves on it. The animation seemed to trigger in the wrong order if I had it set up that way. So that's why it's separated from the base animation, the transform layer, and then the final visible skeleton itself. So now let's take a look at another example here where I was able to add a little bit more animation to make sure that when he did a flip, he wasn't just dancing around and the car actually settles on the ground. So generally, I like to use layered control rigs because they're quicker than baking stuff, and there are a lot of bones on the transformer, and I want everything to be live. In layered control rig, you're not able to use animation layers. You're not also able to see the key values that are actually on this thing, because everything acts as if it's a layered animation where everything is at a value of 0. Even though you see values here, it's actually 0 for the rotations. If I switch the mode over to constraints, you can see that there's a null here being used, and it's driving the pelvis on this animation. So let's remove this and show you an example of how you can use a layered control rig at the very end here to clean up certain stuff. So if I were to take this null and remove it, you can see here that the animation looks like it did in the first example I showed. I can now take this skeletal mesh here, which is the bumblebee one, I can add the FBFK control rig here from the sequence baker. You can use any kind of control rig you want. I'm just showing you how I did it with these tests. So after I added this FBFK control rig here, so if I switch over the bake mode to constraints, I can refresh the blueprint here so that it updates the control rigs. And I can click on the pelvis. And if I were to click on this down arrow here and click world space parent constraint null on selected controls, it'll bake a null that is the new parent constraint for that control. And with the null, I have keys in world space for where that pelvis used to be. So I can scale the null size so that it's easier to see. I can also see that this null actually isn't oriented to the car. So I could decide to clean it up like this, or I can decide to instead use an offsetted null to control the car so that it looks like it's aligned to the bottom of this car. I can find a frame that looks good. I can actually just kill this null. And if I were to click on the pelvis again, I can press this plus button, which will make a null pop down there. Change the size. Go into local orientation space by pressing Control and tilde. Dragging it down, rotating this thing to look like it's matching the bottom of the car. And then instead of using the macro of world space parent constraint nulls on selected controls, I can actually just use this bake control pivot to null offset. So from pelvis here, I just click on pelvis because it's asking me to select a control for pivot offset. And now it's the exact same bake where this null controls the pelvis bone for that control rig, but instead it's offset over to the bottom of the car versus where the pelvis was, and the orientation fits a little bit better. So what I can do from here is just clean up the animation so that the car actually lands on the ground. Now that the car is cleaned up on this one frame, I can just clean up the cues around it to make it look more the way that I'm expecting. It's sloppy, but it's good enough for demo purposes. In this example here, I have Optimus Prime doing a dance, and then he turns into full truck mode. But the difference between this one and the Bumblebee one is this one has the full animation of the truck transforming versus Bumblebee's, which is just a single frame of the car. So you can see in the transformer skeletal mesh here, I have all the different parts here that are animating, but I have two animations here. You can see the transformation itself and then the freeze frame of just the truck. If I were to remove this truck, this thing would not evaluate properly, even though it is set to keep state. You can see here that the slot animations don't seem to evaluate properly without this final frame here being extended. So if I put the animation clip back here, the animation of the truck looks fine. Another thing to notice is that if you scrub really fast, it also looks like it doesn't evaluate perfectly in order. But maybe that's solved in another version of Unreal. If I move slow enough, or if I just press play, the car looks fine. So everything here is animating kind of uniformly. I'm going to try to offset the arm on his left body just a little bit more than the rest, just to exaggerate it a little bit more. I'm going to move the animation clip over to the right and a little bit after all the other animations. And then I'm going to offset the curve from arm L later. Then once all the animations are done, I can actually just bake this out to see it without all the complex control rig going on. I'm going to switch back over to animation sequence, and I'm going to put this animation that is on the body itself into the slot. After that, if I press this P button, it'll copy the name from the animation clip itself. And if I set this unique sequential name to on, it'll put numerical values at the end to not overwrite the original. And it'll put it into the same folder that this animation lives. So if I press the playback mode so that it copies the entire sequence length, I can add the Optimus skeletal mesh because this is the one that's actually driving the final animation. And then I can press bake. And then if I open up the animation clip itself, I can see that it contains Optimus dancing and then him turning into a truck. You can see that the arm is offset too, just the way that I keyed it. So if there was any other tweaks that you would want on this animation and you didn't want everything alone, you could animate on the other animation clip that just popped out with a FK control rig or something like that, or you could animate in this sequencer here. If I wanted to make tweaks before I did that last bake, I can actually just click on the skeletal mesh for Optimus here and make sure that there's no animation clips on it. Add FBFK rig on it. And then I could just move around the controls on the control rig. You can see that because he's squishing himself into this small space that his pivots are in weird spots. So if I rotate, they don't look like they're rotating locally to this thing. So all in all, this workflow is pretty fun and it's pretty flexible in terms of the types of animations that you could do with it. I like to use the animation clips as much as possible whenever I can because Unreal evaluates the animation clips faster than it does any of the control rig stuff. So being able to use the animation clips and then control rigs on top whenever I need it, and then being able to animate on any parts of the mesh that I want, it gives me quite a bit of flexibility in terms of what's possible inside of Unreal and animating directly in it.